Binomial radical expressions. Whenever we're taking the sum or difference of radical expressions, there are two things that you have to look for. First, what we've been looking for, the index of the radical needs to be the same. But when you're adding and subtracting, what's actually underneath the radical, the radicand, also has to be the same. So when both the index and radicand are the same, you can add or subtract radical expressions. When you're adding, you're going to take whatever terms are outside of the radical and add those together, and they remain outside of the radical. The index stays exactly the same, and then the radicand underneath the radical stays the same as well. The same goes for subtraction, except we have a subtraction sign instead. So the only thing that changes are the terms outside. You're going to subtract those two in your final simplified answer. So let's go ahead and work out a couple examples. In this first one, remember, first we need to check to make sure the index is the same. We have 3 and 3, and also that the radicands are the same, 6 and 6. So we can go ahead and add these together and then simplify if possible. So we take the numbers that are outside, 5 and 2, and we want to add them together. So 5 plus 2 is 7, and then we have a radical with an index of 3, and then 6 is our radicand, so that stays inside. Now, we want to simplify this if possible, but 6, if we break this down, is going to be 2 times 3. 2 and 3 are both primes, and we can't break this down any further to get any groups of 3 out. So this is actually our simplified answer. Now let's go ahead and work out example 2. So again, we double check our index. Remember, when the index is missing, it's just square root. And then the radicand 7x and 7x, they're also the same, so we can go ahead and subtract. So we have 4 minus, remember, we're missing our invisible 1. So 4 minus 1 gives us 3, and then we have a radical of 7x. 7 is prime and x is prime, so we can't simplify this any further. So here is our final simplified answer. Now this is a review of things that we've done before, but we want to multiply and simplify these terms, these binomials. So here in this case, we actually want to FOIL this. So let's go ahead and multiply the first terms. 3 times 2 is 6. We'll multiply the outer terms. We have negative 3 times root 5. The inner terms, we have a positive 2 times root 5. And then the last terms, remember, positive root 5 times negative root 5 gives us a negative 5. And then we want to simplify what we can. So here we have an index of 2, the same root underneath. So a negative 3 root 5 plus 2 root 5, that's going to give us a negative 1 root 5. And then if we take our first term, 6 minus 5, we actually have 1. So here's our final simplified answer. Now in the second one, before we multiply, you need to remember what this notation is. We're not distributing that exponent to each term inside. That actually means we're taking 4 plus root 3 times 4 plus root 3. So again, we want to FOIL. So 4 times 4 is going to give us 16. 4 times root 3 gives us a positive 4 root 3. And then 4 times root 3 gives us a positive 4 root 3. And then positive root 3 times positive root 3 gives us a positive 3. So again, we need to combine like terms. We have this 4 root 3 and 4 root 3, which gives us 8 root 3, and that's positive. And then we have 16 plus 3, which is 19. So here is our simplified answer. So here it asks us to rationalize the denominator and simplify. Remember, we always have to rationalize whenever you see a radical in the bottom of a fraction, because we can't have them there. So in this case, where we have 2 terms in the denominator, we have to use the conjugate in order to rationalize it. And remember, the conjugate is the exact same thing as what you see on the bottom, except that middle term is opposite. So we want to put this in parentheses, and then the conjugate is going to be 2 plus root 5. Now if we multiply the bottom of the fraction, you have to multiply the top as well. So we're going to multiply the top and the bottom by the conjugate of the denominator. So on the top, we're just going to end up, because this is one term, we're going to end up distributing this 3 root 2 times 2. That gives us 6 root 2. And then 3 root 2 times a positive root 5. That gives us positive 3 root 10. And then in the denominator, we need to FOIL this because we have two binomials. So 2 times 2 is 4, and then 2 times root 5 is a positive 2 root 5. Negative root 5 times 2 is a negative 2 root 5. And then lastly, negative root 5 times positive root 5 gives us a negative 5. So now we need to go through and simplify. On the top, these do not have the same radicand, so we actually cannot add those together. You can't simplify root 2 and you cannot simplify root 10. So the top is just going to remain exactly as you see it. Now, on the bottom, positive 2 root 5 and negative 2 root 5, those actually cancel out. So we're just left with 4 minus 5, which is actually negative 1. So we don't ever want to leave 1 on the bottom of a fraction, so if we simplify this further, we really just need to make the numerator each term negative. So this is negative 6 root 2 minus 3 root 10, and now we are finally done simplifying this and rationalizing the denominator. So let's go ahead and work out this next example. Same idea. We want to take the conjugate of the bottom, which is going to be negative 1 minus root 3. So remember, we're not changing the sign of the integer, we're just changing the sign of the radical term. And then we need to also multiply the top by that conjugate. So this time we actually have to FOIL the top and the bottom. So let's go ahead and start with the top. 4 times negative 1 is negative 4. 4 times negative root 3 gives us a negative 4 root 3. Negative root 7 times negative 1 is a positive root 7. And then negative root 7 times negative root 3 gives us a positive root 21. And then let's go ahead and FOIL the bottom. We have negative 1 times negative 1, which is a positive 1. Negative 1 times negative root 3, which is a positive root 3. Positive root 3 times negative 1, which is a negative root 3. And then a positive root 3 times a negative root 3, which is negative 3. And then we can go ahead and simplify. Along the top, we have negative 4, and then we have a root 3, root 7, and root 21. None of these three radicals can be simplified, so the top just remains exactly as you see it. There's nothing we can do to simplify that any further. And then along the bottom, positive root 3 minus root 3, that cancels out, so we're left with 1 minus 3, which gives us negative 2. So this is going to be our simplified, rationalized expression. That's it for this set of notes. I'll see you in class for more practice.